Hello and welcome. Please get comfortable, relax, and prepare yourself for a long, calming story. This journey will take you back in time to an era filled with colossal creatures and vast landscapes. If you find yourself enjoying the tranquility of our exploration, consider subscribing to the channel for more serene tales. Now let us drift into the gentle expanse of the Mesozoic era, a time spanning approximately 180 million years, divided into three distinct periods: the Triassic, Jurassic, and Cretaceous. During this age, the planet was a very different place, with lush vegetation and diverse ecosystems dotting the landscape. Gigantic reptiles roamed the lands, filling the skies with their calls, while marine life flourished in the warm, shallow seas. It is a period marked by both wonder and peril, where survival meant navigating a world ruled by dinosaurs, an existence that would challenge even the strongest of spirits. As we delve deeper, let us picture ourselves amidst these ancient giants, feeling the earth tremble under their weight and the air thicken with the humidity of a bygone world. Each step taken on the soil of this epoch resonates with the whispers of life thriving under the vast blue skies. Dinosaurs, an extensive and diverse group of reptiles that roamed the earth during the Mesozoic era, are classified into various types based on their morphological and ecological characteristics. These categorizations primarily fall into two main clades: Saurischia and Ornithischia. Saurischia includes theropods such as Tyrannosaurus rex and Velociraptor, which were predominantly bipedal carnivores, and sauropodomorphs, characterized by their long necks, like Brachiosaurus and Diplodocus, which were typically herbivorous. On the other hand, Ornithischia encompasses a wide array of dinosaurs, including but not limited to Stegosaurus, which possessed distinctive dorsal plates and a spiked tail, and Triceratops, known for its 3 facial horns and large frill. Additionally, this group includes hadrosaurs, also known as duck-billed dinosaurs, exemplifying a variety of forms and functions. These dinosaurs developed complex feeding strategies and exhibited social behaviors, inferred from fossil evidence showing herding patterns. The habitat distribution of these various types of dinosaurs fluctuated throughout the Mesozoic era, adapting to diverse environments ranging from dense forests to open plains. The sheer variety of dinosaurs demonstrates evolutionary strategies, and their fossilized remains provide crucial information regarding their anatomy and potential behaviors. Fossils reveal further insights into their physiological differences, displayed in locomotion, diet, and reproductive strategies, highlighting a complex web of life that existed during this time period. The ecosystem of the dinosaur age was characterized by a complex interplay of biotic and abiotic factors that contributed to its overall structure and function. Various types of vegetation flourished in this era, ranging from towering conifers to flowering plants, which provided a diverse array of habitats and resources for numerous species. The presence of extensive forests and lush foliage contributed to a high level of biodiversity, enabling a wide range of herbivorous dinosaurs to thrive. Alongside these herbivores, carnivorous dinosaurs evolved to fulfill the role of apex predators within these ecosystems. Additionally, the climate and geography of the time influenced the distribution of species and the composition of various ecosystems. The climate during different periods of the Mesozoic era varied, with warm and humid conditions being prevalent, which facilitated the growth of rich vegetation across various regions. Coastal environments including ancient shorelines and estuaries, served as important habitats for both terrestrial and aquatic organisms. Moreover, the interaction between different species, such as predator-prey dynamics and competition for resources, shaped the ecological balance. An array of insects and smaller creatures coexisted, contributing to the complex food webs that existed. The ecological niches occupied by these organisms were highly specialized, allowing for a wide range of adaptive strategies to evolve. Overall, the multifaceted nature of the dinosaur age ecosystem provides a framework through which we can examine the interrelationships among various life forms and their environments. Diverse geological formations, including mountains, valleys, and plains, further contributed to the rates of erosion and sedimentation, impacting the types of habitats available, which ultimately shaped the trajectory of evolutionary processes. Each layer of this intricate system existed in a constant state of flux, influenced by both environmental changes and the biological interactions that took place within these prehistoric ecosystems. During the era of dinosaurs, which spanned approximately 165 million years, the climate and geography of the Earth underwent significant variations. The Mesozoic era divided into three periods. The Triassic, Jurassic, and Cretaceous presented a complex atmospheric environment characterized predominantly by warmer temperatures. In general, the global climate featured high levels of carbon dioxide, which contributed to more humid conditions and facilitated diverse flora across various regions. During the Triassic period, the supercontinent Pangaea dominated the landscape, leading to a climate that was generally arid in interior regions, while coastal areas experienced more moisture due to proximity to bodies of water. As time progressed into the Jurassic period, Pangaea began to break apart into smaller land masses, resulting in an increase in both geographical diversity and climatic variation. This fragmentation allowed for new ecosystems to develop, promoting insular climates and unique habitats. By the time of the Cretaceous period, sea levels rose considerably due to tectonic activities and polar ice melt, giving rise to extensive shallow inland seas. Such formations influenced local weather patterns and created environments conducive to the proliferation of various species of dinosaurs and other organisms. Moreover, these changes in geography led to the emergence of isolated ecosystems, allowing for evolutionary diversification across different regions. These geological and environmental shifts played a crucial role in shaping the life forms that flourished during this time, accommodating vast coniferous forests, expansive desert regions, and tropical wetlands. These ecosystems were home to a multitude of species that thrived in the distinct climatic conditions of their respective periods, revealing the intricate relationship between climate, geography, and the organisms that inhabited Earth at that time. As environmental conditions fluctuated, species adapted accordingly, leading to remarkable evolutionary developments, displaying the dynamic nature of life during the age of dinosaurs. Basic survival techniques in an environment overwhelmingly dominated by prehistoric creatures would necessitate a comprehensive understanding of one's surroundings. The identification of safe water sources is paramount, as hydration is essential for survival. It is important to recognize that clean, drinkable water may not be readily available, hence the need for strategies to purify water through methods such as boiling or filtration using makeshift tools crafted from surrounding materials. Foraging for food, provides another vital skill. One must be capable of distinguishing between edible and toxic flora. Knowledge of local vegetation can prevent nutritional deficiencies and toxic reactions. Techniques for gathering such resources could include distinguishing telltale signs of fruit-bearing plants, while understanding seasonal growth patterns would assist in planning for sustainable consumption. Shelter construction is also integral, particularly in response to harsh environmental conditions or potential threats posed by larger species. Constructing a shelter from available materials such as mud, leaves, and branches can provide refuge from inclement weather or predatory threats. Furthermore, fire-making techniques would be necessary not only for warmth, but also for cooking and protection. Mastery of fire-starting methods, such as using friction-based techniques or spark generation, can enhance the likelihood of survival within a volatile ecosystem. Lastly, navigation skills are critical in such a landscape, as the ability to orient oneself relative to landmarks and celestial bodies may prevent disorientation and aid in locating safe zones. Foraging in the era of dinosaurs would require a keen understanding of the available flora and fauna. Humans would need to identify edible plants, fruits, nuts, and seeds that could potentially provide sustenance. Certain plant species would likely be abundant depending on the region, with varying levels of toxicity. It would be essential to differentiate between those that could be consumed safely and those that could cause illness. The ability to recognize seasonal variations in plant availability could foster a more effective foraging strategy. The gathering of fruits, for instance, would involve an understanding of fruiting cycles, which would vary with climate changes and seasonal patterns. Identifying trees that produce berries or nuts would necessitate an awareness of their specific environmental requirements. Edible roots and tubers would also play a significant role, requiring knowledge of where to dig and the best times to harvest. In addition to plant-based sources, foraging would extend to insects, which could represent a valuable protein source. Ants, termites, and crickets, among others, would be readily available in many environments. Collecting such insects would call for techniques that ensure minimal effort and risk, correlating with a thorough understanding of their nests and habitats. Overall, successful foraging would hinge on several factors, namely, the ability to observe, remember, and react appropriately to the surrounding environment, ensuring sustenance in a challenging epoch. The construction of shelter during the era of dinosaurs would necessitate a thorough understanding of the available materials and the fundamental principles of structural integrity. First, one would need to assess the environment for natural resources such as wood, leaves, and stones. In a prehistoric landscape filled with towering conifers and dense ferns, fallen branches and thick underbrush could be utilized. Utilizing wood as the primary structural component could offer both flexibility and strength. It is advisable to select straight, sturdy branches for the framework to create a basic skeletal structure. Once the framework is established, the next phase would involve covering this structure with leaves, grass, or other vegetation. This thatching would serve to insulate the shelter from temperature fluctuations, a vital consideration when attempting to endure the climatic variations of the era. The thickness and arrangement of the foliage would directly affect the overall insulation efficiency, with denser layers offering greater protection against environmental elements. Furthermore, The orientation of the shelter in relation to prevailing winds must also be considered. Positioning the entrance away from the direction of strong winds can minimize exposure to biting wind chills. The ground level of the shelter may require additional attention to drainage implications. In areas prone to rainfall, elevating the floor or constructing a slight depression could facilitate water runoff, minimizing moisture intrusion and creating a more habitable environment. Thus, employing basic principles of architectural design while being mindful of the surrounding flora and fauna is crucial to developing an adequate shelter to withstand the challenges presented by an era dominated by massive prehistoric creatures. Fire making is an essential skill that would prove invaluable for survival in an era dominated by dinosaurs. The process of creating fire involves several methods, each with varying degrees of difficulty and equipment requirements. The most primitive method is the hand drill technique, which requires a straight wooden spindle and a flat piece of softer wood as a base. By rapidly rotating the spindle between the hands, friction generates heat, which eventually produces a small ember when enough pressure is applied. This ember can then be nurtured into a flame by transferring it to a nest of dry grass or leaves. Another common technique is the bow drill, which incorporates a bow made of flexible wood and a cord to facilitate the spin of the spindle. This method is often more efficient than the hand drill as it requires less physical exertion. While bow drills are effective, they necessitate additional components, such as a sturdy bow and a properly calibrated bowstring, which may not always be readily available in the wild. Beyond creating fire, tool use encompasses a broad range of activities. Early humans utilized various materials, including stone, bone, and wood, to craft tools necessary for hunting, gathering, and processing food. Stone tools, particularly those created through flaking, varied in complexity, ranging from sharp-edged flakes used for cutting to more specialized implements like scrapers for processing animal hides. Achieving a sharp edge requires skillful strikes against a coarse stone with the goal of producing detached flakes that possess a keen cutting surface. The ability to create such tools is predicated upon the understanding of local resources, including the type of stones available and their fragmentation properties, which could differ significantly based on geological formations. Predatory dinosaurs, a diverse group known for their varied adaptations and hunting strategies, occupied various ecological niches during the Mesozoic era. Prominent among these were theropods, which were bipedal, carnivorous dinosaurs characterized by their hollow bones and three-toed limbs. The size of these creatures ranged from small raptors, such as Velociraptor, which measured approximately 2 feet in length, to much larger species like Tyrannosaurus rex, exceeding 40 feet in length and weighing several tons. Theropods possessed sharp, serrated teeth, suited for slicing through flesh. Many exhibited feathers, suggestive of a close evolutionary relationship with modern birds. Their predatory behaviors varied significantly. Some were solitary hunters, while others might have engaged in pack hunting. This hunting strategy can be observed in genera like Allosaurus, which is believed to have hunted in groups to tackle larger prey. The ecological impact of predatory dinosaurs extended beyond their role as hunters. They contributed to the dynamics of food webs and influenced the behavior and evolution of prey species, such as herbivorous dinosaurs. These interactions fostered a complex web of predator-prey relationships, thereby shaping the overall biodiversity of the ecosystems in which they thrived. Herbivorous dinosaurs played a significant role in the ecosystem of the Mesozoic era, facing various challenges despite their plant-based diet. Notably, the sheer size of many herbivores necessitated a great deal of vegetation for sustenance. Large species, such as the Brachiosaurus and Apatosaurus, required extensive grazing grounds to meet their nutritional needs, leading to competition over particular plant species that could support their massive bodies. As a result, these herbivores often roamed in specific patterns, following the seasonal growth of vegetation, which could lead to significant migrations across vast distances. Furthermore, the presence of rising herbivorous populations affected local flora through overgrazing, causing shifts in plant communities. This alteration in plant diversity could, in turn, impact the entire food web of the ecosystem, affecting not only the herbivores, but also carnivores that relied on them for sustenance. Additionally, herbivores developed various physical adaptations to cope with predation threats such as sheer size, defensive behaviors, and in some cases, herd dynamics. While these adaptations were crucial for survival, they also presented challenges. The need to maintain large, stable herds for protection led to complex social structures among certain species, necessitating the development of social behaviors that would ensure group cohesion during migration or when foraging. This social behavior influenced not only daily activities but also reproductive strategies, as individuals needed to balance the need for safety with the necessity of finding mates, often leading to intricate mating rituals and social hierarchies. Natural disasters were a significant